Hello. Currently work at CGI, been here 18 months. Before that, worked in a Tier 1 carrier, so kind of history in the industry, which is where this talk was really born out from. So everybody's read O'Reilly books, and this is basically an example of why you shouldn't follow textbook examples. I'm not the original copyright holder of the original text, it's O'Reilly. I'm not going to disclose any networks that I found to be vulnerable during this process, obviously. All instances have been ethically reported and all of them have been fixed subsequently. So what actually sparked this off was we had a client solution that needed designing, and instead of just using boilerplate config, I thought I'll reinvent the wheel because it's healthy to do it occasionally, test your assumptions, and essentially boilerplate configs are great, but if you don't review them often enough, you can get a lot of tech debt in them and security debt in them for things that change. So I use the RTFM method. That's not RFC 2721. It's just reading the fine manual and using my brain, really. And I picked the O'Reilly Juniper MX series textbook. It's recommended by Juniper. It's a good read. It's very thick, very heavy. There is an ebook available. I recommend using that because, yeah, you don't want to be carrying that around. And it wasn't an MX series device I was doing it on, but all GNOS is equal, right? That's a different talk. So I need to write a firewall to protect this device. It needs new features that we haven't used before. VXLAM's coming out, we're looking at using that and other things. Need to validate the config is going to protect the system, but also allow all the features to operate and the device to kind of be a good internet citizen. So respond to diagnostic packets, ICMP traceroute, path MTU, because we all hate it when people block that because it makes things harder. Chapter 4, the routing engine protection and DDoS. Brilliant chapter, read it. It's got some very good tips and stuff in there. And the key thing that made me find this was this whole allowing that traceroute activity. So as it says here, it's the current best practice. So you're reading that, you think, great. That's where I should be going. That's the type of thing I should be doing. So this is a section that talks about allowing traceroute. It's really tiny. Looks good, right? Hang on. What's that? Anybody see the problem? It's quite small, so let's have it a bit bigger. So what this is saying is when the destination is the router's IP or the router's logical system IP, well, for starters, that actually isn't going to do what they want with this firewall rule, and that's not actually what it ends up applying. When the protocol's TCP and the TTL is 1, then accept. So that's great. For a traceroute packet, you need the kernel to get that so it can respond with the ICMP message saying, I can't forward this. So it's all good. But what's TTL? So for those that aren't kind of really deep in the weeds of how packet forwarding works, it's a mechanism to make sure your packet will not constantly go round and round the internet if it can't find a home. Ripping off from Cloudflare's website, this explains it quite well. When the TTL is 2, it will only go 2 hops. When it's 3, it will only go 3 hops, and so on and so on. But what's the relevance here? So TTL1 means when you've got to this router, it's going to say you can't go anymore to give you that traceroute response. Any packet with TTL1 is going to get through the firewall so it can do that. The internet is full of bad guys. I know this is news to everybody, but we can't think why TTL1's bad, right? It's a healthy thing. It's so we can do this traceroute. It's this diagnostic activity. How do we all manage our routers? Hopefully nobody's still using Telnet. We might use SSH. We might use some form of AS, which is automation as a service. PyConf, Ansible, Contrail, loads of products available. All of these are using TCP. So that's fine. So what that's meaning is TTL1, I can potentially get to that router, but it's fine. Nobody uses these textbooks and puts them straight into production, especially when they're tier 1s, right? Junipers are very common on the internet. I did try and find a stat last night. Apparently 4.9% is routers in general, but that covers enterprise too. I think Juniper have a much larger share within kind of the carrier industry. Some ISPs have previously referenced this book, but it's just an example, right? Nobody's going to completely lift and shift it. Juniper recommend this book all the time. It's recommended to people that are starting out with MXs to try and really understand what it's doing under the hood. It's co-authored by people at Juniper. But again, it's just an example. Wasn't anywhere, was it? So, before I carry on, I'm not going to disclose any of the networks, and it is a plural that I found this on. All instances have been ethically reported and subsequently fixed. And the important thing is don't try this at home. So never do this without permission, because that's Computer Misuse Act, that's territory of potentially getting jail. So trying this out in a lab environment, I'm going to point this out. So using a device that shouldn't have access to the host, verify you can't access the host, work out the distance, and then access the host using a technique. So with that verifying you can't access the host, here's me trying to telnet to the device, left it 30 seconds, didn't connect, so Control-C'd it. Work out the distance, so we use traceroute, 3 hops away, add some IP tables command that I have obscured, run that telnet again, and there we go, there's the router's login banner. So that's not great, is it? When I found that, and then found it on a few networks that I had spoken to the owners about before doing it, you report it to them that it's been found so they can fix it. I've actually reported it to publisher as well, and there is an errata that exists for the O'Reilly book for that to get changed. Because other people, if they just follow that blindly, it is going to cause problems. Run through that really quickly, but is there any questions?
Yeah, if anyone has questions, please come up to the microphone. Don't forget to state your name and affiliation for the people on the webcast.
Hi, Ben, BGP Tools. One of the things, is there any academic institution doing constant scanning for this? This is the kind of thing that, for example, Census and other organizations would, and potentially something like BGP Tools. Not that I would suggest that I would scan for something like this, but this is the exact kind of thing I would scan for.
Not that I found in open source that are doing the specific. Most people will do a TCP scan, and that's going to show up as blocked. Because doing the trace route to work out the hops to then mangle the packet to make sure it's got the right TTL when it gets there, it's not that difficult to do, but it's non-trivial to do that. So not a lot of scanners that I've noticed are doing this.
Another thing, sort of just thinking out loud, it's kind of funny that this is a problem, given that a lot of the DDoS attacks, certainly that I have received, that normally have a randomized TTL. So to some degree, this must be hitting some router control planes. If you receive one of these attacks. Oh, I guess if it's not the router IP, then it doesn't get into the... Okay, never mind. Ignore that previous point.
Any questions online? No? Any more in the room? No? Okay. Then thank you very much, Gary. Thank you.